Here's another rational equation for us to solve. This one's a little more complicated than the previous two because this one has a trinomial in the denominator of one of my fractions. The technique remains the same. I have to find a multiplier that would cancel that trinomial. Now, let me tell you one of the best things to do. In order to determine the multiplier that would cancel the trinomial, the first thing you want to do is try to factor that trinomial. It's a trinomial, so it's going to factor into two binomials. There wasn't a common factor I could take out. Now, wouldn't it be nice if this trinomial had at least one? And actually, what would really be nice is if it had both of those binomials as its factorization, wouldn't it? Well, that might work. A minus 10 and a minus 2 would give me plus 20, wouldn't it? And, yeah, I think that's liable to work. Let's try it and see. The f of FOIL, x times x is x squared. The L of FOIL, minus 10 times minus 2 is plus 20. The O of FOIL gives me minus 2x. The I of FOIL gives me minus 10x. Yes, the product of those two binomials is equal to that trinomial. So multiplying this fraction by that pair of binomials will cancel, won't it? It'll cancel that entire trinomial because that trinomial is equal to those two binomials. Well, if I want to multiply this side of the equation by those two binomials, I have to multiply both terms on this side of the equation by that pair of binomials, which is perfectly fine because it'll cancel those binomials for me. Here, the x minus 10s cancel, leaving me 2 to be multiplied times those two terms of that binomial. 2 times x is 2x. 2 times minus 2 is minus 4. Here, the x minus 2 binomials cancel. Ooh, careful, there's a minus sign, so it's minus 3 times those two terms. Minus 3 times x is minus 3x. Minus 3 times minus 10, minus times minus is plus 30. Equals, well, all that was left here was the 6. Those two binomials canceled that denominator completely. And we've created a nice linear equation we can solve. Let's combine the like terms here. 2x minus 3x is negative 1x. Minus 4 plus 30 is plus 26. And if I subtract 26 from both sides, and then divide both sides by negative 1, I get the solution that x equals 20. We need to remember about the restrictions on x. We need to remember about the values of x that if we plugged it in, it would make the denominator become 0. What value would make this denominator become 0? Wouldn't it be the value of 10 for x? 10 minus 10 would be 0. So 10 is a restriction on x. What would be the restriction that would come from this denominator? Wouldn't that be 2? 2 minus 2 would be 0. So the two restrictions here are 10 and 2, and our solution is not one of those. So we can accept our solution as not being a restriction, but we wouldn't know whether or not it was the correct solution until we plugged it in and worked it out to see.